Hello everybody, I am Laura Lopez, and together with my colleagues I will be presenting our work on multimodal deep learning approach for flood detection. So as everyone else, I am here presenting my work on this multimedia satellite test, but we decided to only focus on the part of flood retrieval from social media images. So the first thing that we did was setting a little bit the state of the art on this test, so flood detection in images, and we saw that there's two major trends, taking satellite, using satellite images or using on-ground images. In our case, we are focusing on on-ground images. And we saw that there was not much work using deep learning approaches, and also no work using multimedia information, multimodal information. So we decided to inspire ourselves in a work presented this year for visual question answering, which also uses metadata, well, text information and visual information. So for the data set, as you know, we have images which may or may not contain evidence of flood, and these images have some metadata associated to it. We decided to only use the title of the image, the description, and the text, if any. And this is a schema of the approach that we use. So we decided to process separately the image and the text. For the image, for extracting the image features, we use the Inception 3 network, which was pre-trained on ImageNet, and we fixed the first layers of the network and just retrained the last layers of the network. And as for extracting the text features, we concatenated the three metadata that we are using: the image, the text, and the title. We use Globe as a text embedding, and then pass it through a bidirectional LSTM. And once we've got the image features and the text features, we concatenated them and passed them through a fully convolutional layer after a softmax classifier to classify between flood evidence or no flood evidence. So we run 4 different experiments. First of all, using only the metadata, then using only the images, then combining both features, and finally we tried to increase the data set because we thought the more the better, especially with deep learning. So we wanted to increase the images from the data set, and for that we used the Google image engine. So you probably already all know how it works. So you upload an image to Google, and it gives you visually similar images. That's an example of it. So we did that with all the images from the dataset, and we gave the images the ground truth from the original image. And we took the 3 top images from Google, and then we manually also looked at the images to make sure that we were not adding any noise to the dataset. So here are our results. We got better results using metadata only as compared to using image only, but we got the best results when combining the metadata information and the image information. And we were a little bit surprised by the results when using extra information. We were expecting to get a little push on it, but we actually got worse results, and we thought that it could be maybe because these images had no metadata information. So as a conclusion, I would say that, as I said before, metadata information gave us more information as the image information, but combining them was the best, and adding extra information did not do the trick for us. Thank you very much.